Hello everybody. In today's class, we shall understand differentiation of implicit functions. So far we have understood the differentiation of explicit functions. You know explicit function? Any function of the form y is equal to f of x is called an explicit function. Explicit function. You know what is the meaning of the word explicit? You know, explicit is something which is very clear. For example, if I take the function y is equal to 2x squared plus 5x minus 1. In this function, we can easily understand that x is one variable and y is another variable, and x is the independent variable and y is the dependent variable. The two variables are very clear, and that's why it is called as explicit function. We can give plenty of examples for explicit functions. Say y equals mx plus c, y square equals 25x. These are all explicit functions. Or even a function of the form y is equal to sin x, y is equal to cos inverse of x squared. These are all explicit functions. But in calculus, we also come across certain functions which are not explicit in nature. I'll give an example. Now look at this function, f of x comma y is equal to 0. This function is called an implicit function. You know, it is implicit function. The meaning of the word implicit means something which is not clear. Here you cannot make out which is the dependent variable and which is the independent variable. For example, look at this function. Say ax squared plus 2hxy plus by squared is equal to 0. Here, both the variables x and y are present together. They are not separate as in this case. Here y is separate and x is separate. But here x and y are present together. Look at this. X cubed plus 3axy plus y cubed equals 27. Again you see x and y are present together. So here you cannot make out which is dependent variable and which is independent variable. Therefore, this is called as an implicit function. In calculus, we come across several types of implicit functions. For example, 5x squared plus 8xy plus y squared plus 6x minus 11y minus 7 is equal to 0 is an example for implicit function. Because x and y are present together and you cannot make out which is the dependent variable and which is the independent variable. In today's class, we are now interested in finding the differential coefficient of those functions which are of the form f of x comma y equals 0, or it could be even f of x comma y is equal to some constant. That constant can be either 0 or any number, but the form of the function should be f of x comma y equals a constant.